Hello, and thank you for tuning in to this demonstration. We are going to take you through two cases today with our Hysopt BIM Syncer bridging the gap between HVAC engineering and BIM modeling. In the first demonstration, we are going to look at the workflow of when we have an existing BIM model, but it is not yet fully calculated. Situations where this may occur are when renovation projects or when a third party has done a preliminary study. Some companies choose to start with a BIM model that is then completed throughout the projects. We are in this last situation with the BIM model you see here. So it's a relatively small BIM model, but it contains some interesting things. For example, we work here with heat interface units, which provides the room with heating, but there are also two connections for domestic hot water that are not drawn in Revit, but which make a big difference in the hydraulic calculations. In addition, we have an underfloor heating collector drawn to collector level and some regime changing elements such as mixing circuits and a radiator. We also see heating and cooling and some hidden open connections like this T-point here. We are now going to use the generate function to generate a Hysopt model out of the Revit model. So here at the top of the menu bar, we can click generate Hysopt model. And now the software is going to analyze the topology of the BIM model to generate a Hysopt model. When we generate, Revit's components are automatically mapped onto Hysopt's components. So this means that every object in Hysopt has a twin in Revit, but also that every object in Revit has a twin in Hysopt. This way, we can easily navigate between both models and see that the pipe lengths are synchronized. Now we can go to our engineering functionalities. So we use the three calculation steps above for this, with the first one being the system check. So with the system check, we are going to verify whether the hydraulic design as drawn in Hysopt complies with some basic rules and whether it could actually work. So we see here that several components light up red, and those indicate that there is no pump present for this end unit. This means that when a measurement state is made of the current BIM model, that there will be pumps missing, which will not be noticed until much later in the process and thus may involve delays for the entire project. We also see that in Hysopt schematic layout, it is much easier to see whether pumps are present than in Revit's 3D model. And if it is still difficult to detect whether the pumps are positioned correctly, Hysopt System Check will always inspect this for you. Next, we can start filling in missing information from Revit in Hysopt. And what exactly do I mean by this? Well, Revit does not know what its components physically represent. For example, this heat exchanger is for Revit a component with four connections and some parameters. But it doesn't know that this is a heat exchanger, which is rather important for physics and for all the hydraulic calculations. So we can now add this information in Hysopt. So here we indicate that this is a heat exchanger, and that way the correct formulas are going to be used when calculating the system. We can do the same for the heat interface units, of which Revit also doesn't know that this is a heat interface units. So here we choose a direct HIU. And we can also add to the floor heating system in Hysopt. That way, a certain temperature regime is added here. Next, we take into account the mixing circuits. So there's a regime change in the system. and we can adjust the capacity of the radiators to our requirements. Now that this is done, we can move on to the second calculation step, which is the compute design flows, or the calculation of design flow rates. In this step, the design flow rates through the installation are calculated using the capacities and temperature regimes. But at a domestic hot water connection, we are also going to consider diversity and the domestic hot water. So even though we didn't draw this in Revit, we take this into account in a calculation so that the correct pipe and component selections can be made. At a regime change in the underfloor heating circuits, we see here 0.12 cubic meters per hour as a design flow rate. But due to the change in temperature, we only have 0.02 cubic meters per hour on the primary side. So this is a big significance, which can also have a significant effect on the correct pipe selections. After that, we can do our pipe selections based on these design flow rates for which we support multiple standards. So for example, we have WTCB for Belgium, ISO 18 for the Netherlands, and CIPSE for the UK. And today we're going to use the ISO 18, for which we have been validated by ISO themselves. So with a single click on a button, we can now run the whole pipe selection on our system. And the nifty thing of doing this in a digital way, so with our Hysopt software, is that if an alteration comes from the client, who indicates, for example, that new building simulations show that 4,000 watts per room is sufficient, we can recalculate this very easily. So diversity and regime changes are again taken into account, and adjustments in pipe selections can be made with a single click. At this point, we have finalized our design and we want to upgrade our BIM model that already existed to a more and better, more correct and better system. For this, we use the validate function. So with this functionality, we are going to compare both models with each other. So each component has a twin in the other interface. And so we can compare data from both worlds with each other. So we are going to generate a validation report, which will show the comparison between both models based on various criteria. So here it shows some warnings. The first one is about spaces which do not have a zone allocated in Hysopt, but that is not that important for this demonstration. But here it indicates as a warning that the object in Revit is not seen as a heat exchanger in Revit, while we did have defined this in Hysopt. So this is an example that Revit doesn't know that this is a heat exchanger unless standardized libraries are used. Lastly, here we have the pipes. So we see that it detects a difference between the pipe diameters in Revit and the ones in Hysopt. And this makes sense because we have just performed the correct calculations in Hysopt, and now we want to transfer them to our Revit model. We can do this by clicking on the pipe and then simply synchronizing it. So if we take a closer look now, we see that this pipe, as well as the bends and the T-joints with which it is connected, are updated according to the correct pipe calculation, which we did in Hysopt. We can now do this for the whole system. With one click on the button, we are going to synchronize all pipes calculated by the ISO 18 standard to Revit. Okay, and it's already done. Now we can check that, for example, the pipe at the boiler has been giving a diameter of 40, and that is correct. So next we will rerun our validation report to check whether our new updated systems are a perfect match. Okay, so we see that new errors have appeared, and this has to do with the pipe lengths. Because we just adjusted the diameter in Revit, the lengths of the pipes were readjusted because the bends, T-joints, etc. were resized. This is a perfectly logical result, and also a great example that a calculation model and a 3D model will always affect each other, and that it's an iterative process to fully align and optimize them. So now we transfer the pipe lengths to the Hysopt model in one click, in case, for example, pump heads should be calculated in the future. And now we run our validation again and see that we are now only left with the warnings from the beginning. And in the background, Hysopt checked all these other issues as well. So now we can download this validation report and it can be sent along to the client as proof that the P&ID and the BIM model fully match. We can also place the Hysopt model on a Revit sheet if we want to. And this can then be delivered along with the project to the client. Okay, so this was our first demonstration. We started from an existing BIM model that had not yet been fully calculated correctly, and we were also uncertain whether it still contained hydraulic errors. We then used the generate function to generate a Hysopt model where we could easily see that some pumps were missing. And then we did our design calculations correctly by taking receipt changes and concurrency into account. And lastly, we carried out the pipe selections according to the standard and synchronized that back to our BIM model. And all of that in a span of a good 10 minutes. So now we can move on to our second demonstration where we assume a different workflow, which is that the BIM model and the calculation model are built in parallel. So there are two teams. We have a team of engineers and one of modelers, and we are going to be in the shoes of an engineer today. So we are going to create the P&ID design and then see if the BIM model created matches and meets the design as we did as an engineer. So we can create our P&ID in this Hysopt interface, but we can also do it entirely in the browser as well. So we go to our account in the browser. So that way you don't need a Revit license as an engineer to create a P&ID with Hysopt. So we'll now make our model. Just give it a name and then we can get started. Now we get to our canvas. Here we can use the Hysopt library to build our P&ID. So again, we use the engineering functionality of Hysopt. We are going to use a simple system today, which is a boiler and a pump, and then some radiators as end units in our model. So you can see this way we can build a P&ID relatively quickly. We also add zones to the radiators, and they each get a thermostat as well. So our P&ID is ready in terms of topology, and now we can go through our calculation steps. So we can work with a certain capacity for our end units. And then we first run a system check to see if this system can work, and that seems to be okay. Then we can go to our design flow calculation and our pipe diameter selection, for which we will again use the ISO 18 standard from the Netherlands. Our P&ID is now ready. So we save it and then we can go back to Revit to open our P&ID there. So here we open our created P&ID, and now we can see if the BIM modelers have done their job correctly. So in the first step, we are going to link both models to each other. And in the first demonstration, where we converted a Revit model to a Hysopt model, each Revit component had a Hysopt component immediately linked to it. But since both models are now built in parallel, we are going to use the BIM Syncer's mapping assistant. So the mapping assistant is a way to link a Revit component to a component in Hysopt. Remember that if a check happens, um, so nowadays in real life, if a check is done between the components in the BIM model and the calculation model, it is often still done manually. So it is this process that we have digitized here. The advantage is that this can be done much faster now, and once it is done, it is very easy to make adjustments afterwards. A second big advantage is that we can use a smart algorithm that will help us do the mapping faster, so that we can link both models to each other quite quickly. So, depending on the things that have already been mapped, the algorithm will understand the topology of the installation better and better, and we can see how the installation will map itself. And then once we have mapped everything, we can use the validate and synchronize functions again. So we once again generate the validation reports, and we are receiving some warnings for spaces that do not have a high subzone, but that's okay. Here, there's another interesting thing that the Hysopt BIM Syncer detects. So it sees that there's a component in Revit which has another classification than the component which we as an engineer used in Hysopt. So we said this must be a balancing valve, while the BIM modeler has placed a control valve here. If this is not noticed in time, a control valve will be ordered, and in the worst case, the control valve will arrive on site. But we can now adjust this to the correct component, and then this will not happen. So we notice the same problem with the shutoff valve, which is supposed to be a non-return valve. So here we select the non-return valve. And now we do another validation to see whether the Hysopt BIM Syncer agrees with the adjustments we have made. And now we see that all adjustments have been done well. In the background, there are some other components which have been validated as well, as you can see here. And then next, we have our pipes that can be synchronized again, just like we did in the first demonstration. So this was the second example of how we can use a Hysopt BIM Syncer to detect errors and make your work more efficient. Thank you for tuning in, and make sure to contact us if you have any other questions regarding our Hysopt BIM Syncer.